In level 3, we will be using relationships involving area and perimeter to compute another measure. So these are just going to be a little bit more complicated from level 2. In this first example, we need to find the area of a shaded region. If you imagine this figure made out of construction paper and I wanted to find the shaded part, I could cut out the circles on the inside and be left with the shaded region. So kind of using that idea, I can find the area of the big circle and the areas of the smaller two circles and subtract them, and I would be left with the shaded region. So I need to find the area of all three circles. Remember that the formula for the area of a circle is pi r squared. And so we need the radius of all of these circles. The small circle has a radius of 2. So the area would be pi times 2 squared, or 4 pi. The medium circle, the area would be pi times its radius is 3, so 3 squared, or 9 pi. And then for the big circle, we're not given the radius, so we need to figure it out. So using this diagram, since the small circle had a radius of 2, its diameter would be 4. And the medium circle has a radius of 3, so its diameter is 6, which means all the way across the big circle would be a diameter of 10, giving the big circle a radius of 5. So for the big circle, the radius is 5. I do pi times 5 squared, and we get 25 pi. And now to find the area of the shaded region, I'm going to do the big area minus the two smaller circles. So 25 pi minus 4 pi minus 9 pi, and it's kind of like combining like terms. I can subtract those since they all have pi in them, and we get 12 pi. This is the exact area of the shaded region. To find a decimal approximation, we're going to plug 12 pi into our calculator and get a decimal. That comes out to about 37.7 square units. In this next example, we have sort of a complicated composite figure. And to find its area, we need to break it apart into smaller pieces. So I would break it apart into a right triangle, a semicircle, right here, and a rectangle. If I start with the triangles area, I do 1/2 base times height. And remember that the base and height have to make a right angle. So the base and height of this triangle are going to be the side I don't know and the 4. Since I don't know that side, I can use Pythagorean theorem to find it since it's a right triangle. And this is actually one of my triples, so it's good to remember your triples. It saves you time. If I have a hypotenuse of 4, or of 5, a leg of 4, the other leg must be 3. It's a 3, 4, 5 triangle. So the base and height of this triangle would be 3 and 4. So 1/2 base times height is 1/2 times 3 times 4, which gives me 6 square centimeters. And next time I do the rectangle, because that's just length times width. So 8 times 12, which gives me 96 square units. And lastly, I would do the semicircle. A semicircle is half of a circle. So for the semicircle, I'm going to do 1/2 times pi r squared. So the area of a full circle is pi r squared. I need to cut it in half because it's only half of a circle. And I need the radius. So the radius is half the height of this rectangle. Since the height of that rectangle is 8, the radius of this circle would be 4. And so for the area of the semicircle, I get 1/2 times pi times 4 squared, which is 1/2 times 16 pi, which gives us 8 pi. And now for the area of the entire figure, I had an area of 6 square centimeters for the triangle, 96 square centimeters for the rectangle, and 8 pi for the semicircle. I add those all together. 6 plus 96 plus 8 pi. Now since I'm asked for exact form, I can't combine 8 pi with the 6 and the 96. So I get 102 plus 8 pi. That's my exact answer.